Good morning, chemistry students. Here's a video about going over the corrections for the balancing chemical equations worksheet that you did as homework. So, before we even start to balance these, yesterday we talked about decomposition reactions. So what I'd like to do is to look through these first 9 reactions and see, do we have any decomposition reactions? Now, what are we going to look for again? Remember, to identify something as a decomposition reaction, we're going to look for the fact that we only have one reactant and we have 2 or more products. Well, the only reaction here that has one reactant is reaction number 2, and it does indeed have more than one product. So this actually is a decomposition. Okay. Reaction. And that was what we had talked about yesterday. So, going through balancing these. Again, 2 nitrogen here and only 1 nitrogen here. So I need a coefficient of 2. 2 hydrogens here, and we have 3 hydrogens, or actually 6 hydrogens here. So I need a coefficient of 3. I'm going to double check that my reaction is properly balanced here. So I have 2 nitrogens and 2 nitrogens. I have 6 hydrogens and I have 6 hydrogens, so this is balanced. All right, moving on to number 2. I have 1 potassium here and I have 1 potassium here. I have 1 chlorine here and I have 1 chlorine here. I have 3 oxygen on the reactant side and 2 oxygen on the product, so I'm going to be able to make them both a 6. To get 6 oxygen on the reactant side, I need a coefficient of 2. To get 6 oxygen on the product side, I need a coefficient of 3. Now that has changed my potassium and chloride and chlorine. Now I have 2 potassium and 2 chlorine, so I need a coefficient, a coefficient of 2. Now checking my ratios, 2, 2, 3, that's the lowest whole number ratio, so now I'm just going to verify that it's correctly balanced. 2 potassium, 2 potassium, 2 chlorine, 2 chlorine, 6 oxygen, 3 times 2, 6 oxygen, it is properly balanced. Number 3, I have 1 sodium, 1 sodium, 1 chlorine, 2 chlorine. So I need a coefficient of 2 in front of sodium chloride. 2 fluorines, 1 fluorine. So I need a coefficient of 2 in front of sodium fluoride. And I think that it's properly balanced. I'm going to check it. So 2 sodiums, 2 sodiums, 2 chlorines, 2 chlorines, 2 fluorines, 2 fluorines. This is properly balanced. Number 4. We have 2 hydrogens and 2 hydrogens, so that's fine. 2 oxygens and only 1 oxygen, so we need a coefficient of 2. Now remember, before our hydrogens were balanced, so now they aren't anymore, so I need a coefficient of 2 in front of hydrogen. I think it's balanced. I'm going to do a double check. 2, 1, 2 is the lowest whole number ratio of coefficients. 2 times 2, that's 4 hydrogens. 2 times 2, that's 4 hydrogens. 2 oxygens, 2 times 1 is 2 oxygens. This is properly balanced. Number 5. We have 1 silver and 1 silver. Again, we're going to do nitrate as a group, so we have 1 NO3 here and we have 2 NO3s here. So to balance those, I need a coefficient of 2 in front of silver nitrate. I have 1 magnesium here, and I have 1 magnesium here. I have 2 chlorines here, and I only have 1 here. So I need a coefficient of 2 in front of silver chloride. I believe it's balanced, and 1 or 2, 1, 2, 1 would be the lowest whole number ratio. So I'm going to, of coefficients, so I'm going to double check. So I have 2 silver and 2 silver. I have 2 nitrates and I have 2 nitrates. I have 1 magnesium, I have 1 magnesium. I have 2 chlorines and I have 2 chlorines. It is properly balanced. Number 6. 1 aluminum, 2 aluminums. So I need a coefficient of 2 in front of aluminum bromide. 3 bromines, 1 bromine. So I need a coefficient of 3 in front of potassium bromide. I have 2 potassiums and now I have 3. So that's not going to work. Okay. So I'm going to try to make 6. So I'm going to do a coefficient of 3 here, which means I need to change this 3 to a 6. One sulfate, and I have 3 sulfates. Sorry, I actually have 3 sulfates here, and I have 3 sulfates here. I have 6 bromines, and I have 6 bromines. So I think it's balanced. Let's double check. 2 aluminums, 2 aluminums. 6, 2 times 3 bromines, 6 bromines. 2 times 3 is 6 potassiums, 6 potassiums. 3 sulfates, 3 sulfates. So it is properly balanced. Reaction number 7. Again, remember, I want to try to leave hydrogen and oxygen until the end. So I'm going to start with my carbon. I have 1 carbon and 1 carbon. So when I'm deciding whether I want to go to oxygen or hydrogen next, I choose to go to hydrogen because hydrogen is only in 1 reactant on the reactant side and only in 1 product on the product side, which probably means it will be a little bit easier to do than oxygen will be. So I'm going to look at hydrogen next. I have 4 hydrogens here, and I only have 2 here, so I need a coefficient of 2 in front of water. Now, oxygens, I have 2 here. I have 2 here, plus 2 more here, so that's 4 altogether. So to get 4 on the reactant side, I need a coefficient of 2. I believe this is properly balanced. I'm going to check it. 1 carbon, 1 carbon, 4 hydrogens, 2 times 2, 4 hydrogens, 4 oxygens, 2 times 2, I have 2 here, plus I have 2 here, that makes 4 oxygens. It is correct, and 1, 2, 1, 2 is the lowest whole number ratio of coefficients. Reaction number 8. I have 3 carbons here, and I have 1 carbon here, so I need a coefficient of 3. I have 8 hydrogens here, and I have 2 hydrogens here, so I need a coefficient of 4 in front of water. I know on the reactant side that I have 2 oxygens, so I'm going to look at how many I have on my product side. I have 3 times 2, which is 6, and plus 4 more, that makes 10. So to get 10 oxygens on the reactant side, I need a coefficient of 5. 1, 5, 3, 4 is the lowest whole number ratio, so I'm going to double check it. 3 carbon, 8 hydrogen, 4 times 2, 8 hydrogen. I have 10 oxygen here. I have 3 times 2, which is 6, plus 4 more, which makes 10, so this is properly balanced. Our last reaction, we have C8, H18. So again, I have 8 carbons here, and I only have 1 carbon here, so I need a coefficient of 8 in front of carbon dioxide. I have 18 hydrogens here, and I have 2, so I need So I need a coefficient of 9 in front of water to get 18 hydrogens. And then I know I have 2, but I'm looking over here, so I have 16 plus 9, which is 25, which poses a bit of a problem. And this is going to happen with some regularity with these types of reactions. So here's a trick, right? I need 25 oxygen, and I can't get 25 when I have O2. So the trick is, when I need an odd number, I'm going to put that odd number I need over 2. Now, I can't have a coefficient that is a fraction. So how do I get rid of that 2? I'm going to multiply all of my coefficients through by 2. So right now, my coefficient here is 1. I'm going to multiply that by 2, and it's going to become a 2. Again, 25 divided by 2 multiplied by 2 is going to become 25. Okay. This 8 multiplied by 2 is going to become 16. And this 9 is going to become 18. So I'm going to kind of clean this up a little bit by erasing, and then we'll do a double check. Okay? So this is a 2 now. We said this one became a 25. This one became a 16. And this last one became an 18. So, to check now, 2 times 8 is 16, 16 carbon. 2 times 18 is 36 hydrogen. 18 times 2, that's 36 hydrogen. 25 times 2 is 50 oxygen. I have 16 times 2, which is 32 oxygen, plus 18 oxygen, which gives me 50 oxygen, which is how many I have on the reactant side. 2, 25, 16, 18, that's the lowest whole number ratio of coefficients, so this is properly balanced. Question number 10. 1 iron, 1 iron, so that's okay. 3 chlorines. Over here I only have 1, so I need a coefficient of 3 in front of sodium chloride. 1 sodium, and now I have 3 sodium, so I need a coefficient of 3 in front of sodium hydroxide. I have 3 hydroxides, and I have 3 hydroxides. So I think it's balanced, and 1, 3, 1, 3 would be the lowest whole number ratio. I'll double check. 1 iron, 1 iron. 3 chlorines, 3 chlorines. 3 sodiums, 3 sodiums. 3 hydroxides, 3 hydroxides. It is properly balanced. Number 11. 1 phosphorus, 2 phosphorus, so I need a coefficient of 2 in front of phosphorus. 2 oxygens, 5 oxygens. So again, I'm going to need to make them a whole number, so the best whole number is going to be to have 10 oxygens here, which means I need a coefficient of 5 here. Now that's changed my phosphorus. Now I have 4 phosphorus here, so I need to change this coefficient here on phosphorus to a 4. 4, 5, 2, that's the lowest whole number ratio. I think I'm done. I'm going to check. 4 phosphorus, 2 times 2, 4 phosphorus. 5 times 2, 10 oxygen. 2 times 5, 10 oxygen. This is properly balanced. 1 sodium for number 12. 1 sodium. 2 hydrogens. 2 hydrogens. 1 oxygen. Oh, there were 3 hydrogens. Oops. All right, so let's try making this 6. So let's make this a coefficient of 3. And now we have 3 oxygens and we only have 1 oxygen. So let's try our coefficient of 3, which means we have a coefficient of 3. So let's see how that does. So we have 3, 4, 5 oxygens. Nope, those aren't going to work. So let's kind of start over again. So we have, right, if we kind of look at this as possibly HOH, let's see if it makes it a little bit easier. Because again, the idea being this hydrogen becomes this hydrogen, and this hydroxide becomes this hydroxide. So let's see if that makes it a little bit easier. Sodium's already fine. It's the water that's the challenge here. So I have, based on this, I have 2 hydrogens here and I only have 1 here. So let's try a coefficient of 2. And now I have 2 hydroxides, so I need a coefficient of 2 in front of hydroxide, which means I also need a coefficient of 2 in front of sodium. Now, I think I'm balanced. I'm going to take this, and I'm going to put my 2 up here, just so that I don't forget. So let's do a check now. I have 2 sodiums. I have 2 sodiums. I have a total of 2 times 2, 4 hydrogens. I have 2 hydrogens here plus 2 more here. That's 4 hydrogens. I have 2 oxygens and I have 2 oxygens here. So this is balanced. 2, 2, 2, and 1. Lowest whole number ratio. So that is properly balanced. Again, that's another example of having that hydroxide as a product may mean that writing water as HOH makes it a little bit easier. Number 13. 2 silvers, 1 silver, a coefficient of 2 in front of silver. I have 1 oxygen, I have 2 oxygens. I need a coefficient of 2 in front of silver oxide, which means that my 2 that I had here is incorrect. And now I need a 4. I think it's balanced, and 2, 4, 1 is the lowest whole number ratio coefficient. So I have 2 times 2, which is 4 silver and 4 silver. I have 2 oxygens and I have 2 oxygens. This is properly balanced. Number 14. 8 sulfur, 1 sulfur. I need a coefficient of 8. I have 8 times 3. Okay, which is 24 oxygen. So I need 24 oxygen on my reactant side. So I need a coefficient of 12. 1, 12, 8. That's the lowest whole number ratio. I think we're balanced. We'll check it. Again, 8 sulfur, 8 sulfur. 12 times 2, 24 oxygen. 8 times 3, 24 oxygen. This is properly balanced. Number 15, I have 1 carbon here, I have 6 carbons here. So I need a coefficient of 6 in front of CO2. Again, I'm going to go to hydrogen next because I think it might be a little bit easier to deal with hydrogen next. So I have 2 hydrogens here and I have 12. So I need a coefficient of 6. So that brings me to my oxygens. I have 6 times 2, which is 12, plus 6 is 18 total. So here I have 6, and then so if I take my 18 and I subtract my 6, right, that leaves me with needing 12. Somehow I need to get O2 to be 12, which I can do with a coefficient of 6. I think it's balanced. I'm going to check. So 6 carbon, 6 carbon. 6 times 2 is 12 oxygen. 6 times 1 is 6 oxygen. So I have 18 oxygen on my reactant side. I have 6 oxygen plus 6 times 2 is 12. So I have 18 oxygen on my product side. And then checking my hydrogen, I have 6 times 2, which is 12 hydrogen, and I have 12 hydrogen. This is properly balanced. All right, potassium. 1 potassium, 1 potassium. 1 magnesium, 1 magnesium. 2 bromine, 1 bromine. So I need a coefficient of 2 in front of potassium bromide, which means I need a coefficient of 2 in front of potassium to make sure I also have 2 potassium. I think I'm balanced. 2, 1, 2, 1, lowest whole number ratio of coefficients. Checking now, 2 potassiums, 2 potassiums. 1 magnesium, 1 magnesium, 2 bromines, 2 bromines. So it is balanced properly. And number 17, 1 potassium, 1 hydrogen, 2 hydrogens here, so I'm going to put a coefficient of 2 in front of hydrogen chloride. 1 chlorine, 2 chlorines, and we have 2 chlorines here, so that looks okay. 1 calcium, so that looks okay. 1 carbon, so that looks okay. 3 carbons, or oxygens. I have 2 here plus 1 here makes 3. So I think this is balanced, and a 2 is the only coefficient, is definitely the lowest whole number ratio. Checking 2 hydrogens and 2 hydrogens. 2 chlorine and 2 chlorine. 1 carbon, 1 carbon, 1 calcium, 1 carbon, and then 3 oxygens, and I have 1, 2, 3 oxygens, so this is properly balanced. So I hope that helps if you had some questions about the homework.